All right, so we have our Unit 6 test tomorrow. I will open it up right after this, and you guys can go ahead and get started on it if you'd like. Um, Otherwise, you can do it tomorrow, but it has to be done tomorrow. If it's not done tomorrow, it'll be a 0. All right, has everybody got that? 0 if it's not done tomorrow. I'll put that again on the announcements. So to simplify, the first thing that you guys are going to do is multiply your two numbers. So we're going to multiply 4 times 2, which gives us 8. And then you're going to tell me how many total x's and how many total y's. So in this one, there are 4 x's and there are 2 x's, which makes a total of 6 x's. And then we have 3 y's and 2 y's, which makes a total of 5 y's. That's it. Okay. The next one, remember when we have a power, we're going to write it out. So we have this 3 times 3xy cubed, 3xy cubed, 3xy cubed. We do it 3 times, and then we do exactly what we did on the first one. Multiply your numbers together. 3 times 3 is 9, times 3 is 27. And then you count your total x's. So we have 1x right here, 1x right here, and 1x right here, which makes a total of 3 x's. And then you have 3 plus 3 plus 3, which is 9 y's. So again, anytime you see a power, your test is going to look exactly like this. Write it that many times. So if it was a 2, just write it twice and then do the same thing. All right, to divide, oh my gosh. To divide, you're going to see if there's anything the same on the top and the bottom. I showed you this way. You have a 3, a U, and 4 V's. On the bottom, you have a U and a V. Anything the same on the top and the bottom, we can cancel out. And then we just write what's left. On the top, we had a 3 and 3 V's. And that's it. All you got to do. All right. Remember also, if you have anything to the 0 power, it's 1, so you can mark it out. So I can mark this y to the 0 out. Also, if I have negative exponents, I need to move them. So if they're on the bottom, I can move them to the top. If they're on the top, I can move them to the bottom. So this y is going to go to the bottom. This y is going to go to the bottom. So what I have now is 2 and x on top. I have a y. I have an x squared, and I have a y. If I write that out, I have a 2 and an x. I have a y, 2 x's, and another y. If it's the same on the top and the bottom, I can cancel it out. So we can cancel these x's out. And then we write our leftovers. We have a 2 on top. We have an x and 2 y's. And that is it. Any questions? Number 4. Watch those negative exponents, move them from top to bottom. Bottom to top, either way. All right, try to keep that one on there while I look at the next one. All right. So again, anything to the 0 power is 1. So this x is 0 would cancel out. But if you guys look, this whole thing is to the 0, so we can just mark it all out. On the top, I have 2 x's, 3 y's. On the bottom, I have a 2, 4 x's. What do I do with this y to the negative third? Move it up. But how many of those do I have? What's the power tell me? 3 times. I also have to do this 3 times. So y, 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 y. Looks crazy, right? Not too bad. If it's the same on the top and the bottom, I can cancel it out. So the only thing I can cancel out are 2 of the x's. What did that leave me with? Count your y's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 lies. On the bottom, multiply your numbers. 2 times 2 is 4, times 2 is 8. And I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 X's. That's what your answer would look like. All right, so just be careful. All right, so remember, all you have to do is get 7 of them. So if you miss that one, just make sure you make it up somewhere else. Not a huge deal. Don't stress out about it. Do the best that you can. So then these are really easy and people tend to mess them up. All you do is plug in. We're going to plug in 2 for the variable. We're going to stick it right here. And we're going to use our calculator. -3 times 4 to the 2 minus 1. You literally just put that in your calculator. -3 times 4 to the 2 minus 1. What did it give us? -12. I'm going to just talk to myself today, I guess. Cool. Next one, plug in 2, just like you did before. So in my calculator, I'm going to put in 2 times 2 to the 2 minus 1. 2 times 2 to the 2 minus 1 gives me 4. That's literally all you do, guys. To solve these equations, this first one, all you have to do is change your base of 9. We don't know how to do it any other way other than that. So how can I write 9 if I'm doing base 3? So 3 to the negative k is going to stay. 3 to the what gives me 9?
3.
Not 3 to the 3. That's 3 times 3, but 3 to what power gives me 9? Yeah, so if I did it like this, 3 to the 1, that didn't give me 9. 3 to the 2, did that give me 9?
Yeah, sorry.
It's okay. It's okay. Everybody does that. 3 times 3 is 9. I get it. No worries. So then what you can do is just mark out your 3's and you're going to solve this equation. -k equals 2. How do I solve? This is from week 1. How do I solve this to just have k?
Divide by -1.
Thank you. And I get k equals -2. Now the other ones already have the same base. So you can just go ahead and mark those out and solve 2b plus 3 equals -b. I need to get my b's on the same side. Typically I'd move this one, but I'm going to move this one. The reason I'm not moving this one is because this one's already by itself. It doesn't matter if you put it over there, that's fine. It doesn't matter which order. But I'm going to subtract this 2b. I get 3 equals -3b. We're going to divide by -3. And we get b equals -1. All right, let me show you something else. Try to get this over here. I'm going to stop this share for a minute. Trying to pull up Desmos, just give me a second. If you have Desmos and you can pull it up on your phone or your calculator, I mean, not your calculator, your phone or your laptop, and you put these in, 2 to the 2b plus 3. Nope, stay up there. Hold on, I got to do it in parentheses. That's the hardest part, is trying to figure out. Let's do 2x plus 3 equals 2 to the -x. Look at where this line is. Where's this line at? What kind of one?
Negative.
-1. That's what we got, right? So let's look at number 10. I'm going to show you how to put number 10 in. Again, the hardest part is typing it in. 2 and that little mountain key. So shift 6, 2, shift 6. Parentheses 3 minus x. And again, just use x's. You're going to do an equal 2 and then the mountain key, parentheses, -2x. Where's the line at?
-3.
Oh, yeah, that's your answer. And this is the calculator that you use for your final exam. So did I do any work? I just have to know how to type it in. And again, sometimes that's a little bit hard. Just make sure you use those parentheses. So I'm going to stop this share and go back to my other one. And I'm going to solve it by hand too, so that you guys can see that as well. So we found out this one was -3. How do we get that? We mark out our 2's. We get 3 minus n equals -2n. We're going to add n to both sides. That's 3 equals -n. And then we divide by -1. And if you guys look, n equals -3. I don't care if you use Desmos on your test, okay? I do not care. Any questions? All right, so that's goal 1. So if you can get 7 of those, remember it goes in as 100 in the grade book. Okay, 7 of those is what you need. 3 of those you can use Desmos on if you can make sure that you can plug it in right. All right, look at your next one. Sorry, it's a mess up here. We're going to look at our exponential equations. Remember, it's y equals the y-intercept times the multiplier to the x power. If the multiplier is between 0 and 1, it's going to be decay. If it's greater than 1, it's going to be growth. So yeah, basically 2 questions on this, and that's it. So determine the y-intercept. So which one's the y-intercept? 9 or 1/4? 9. Does the equation represent exponential growth or decay? So we're looking at this 1/4. Is 1/4 in between 0 and 1, or is it greater than 1? In between, so it is decay. That's all you guys have to do. The next one is the same exact way. Where's your y-intercept? .63. Thank you, Justice. Great job. And is this one growth or decay? Look at this number right here. Is it between 0 and 1, or is it greater than 1? Greater, so it's 0. Perfect. Guys, you can have your notes out. I'm not going to be there. Please don't get those 2 wrong. Please. Those 4 are super easy. All right, so then it says the following table shows the results from a situation similar to the Pay It Forward movie. Typically, if we're in class, we watch the Pay It Forward movie. That might be something that we can do soon. I don't know. I have to talk to Ms. Burkhardt. Write an exponential equation to describe the situation. So I showed you guys how to do it on your calculator, right? Remember to put the chart in? The only difference is you guys did linears. Make sure you do exponential, okay? So we're going to go into stat. And remember, this video will be posted after today, after this class. We're going to change our L1, 0, 1, 2, 3, 4. I don't need the 5. And then it says 1, 5, 25, 125, and 625. And I don't need this last one. I will also show you how to do it by hand, okay? So put it in your table. X is in L1, Y is in L2. You go to stat, calc, exponential regression. We go to 0. And we hit enter. And it tells you the equation. Y equals, what's your first number? What's our y-intercept? 1. What's our multiplier? That's our b, our second number. And then make sure it's to the x. Okay, so it should look like this. How else can you do it? Remember, whatever's with the 0 is where you start. How did I get from 5 to 25? 25 to 125. a multiplier of 5. So you don't need the calculator, but it kind of helps you a little bit. Helps you be lazy. Everybody good? All right, remember our next now. The only difference in the next now is that we have a multiplier. And what did we multiply by? 5. And where did we start? So start at 1. That's it. Next nows are very easy. Four more for goal 2, okay? 4 more. It's kind of the same thing. Going to do the same thing. Write an exponential equation. If you need your calculator, use it. Guys, realize that you don't need a million of these points in. You can do 3. So 0, 1, 2. Watch this. 360, 120, 40. Don't care about these two. 3 should give it to you. Stat, calc, exponential. And what's our equation? Y equals, what do we start with? And then you can give me the 0.3 to the x, that's fine. But do you guys know what 0.3 repeating is as a fraction? You might see it as 1/3. Okay, so just watch. So what's my next now? Next equals now. What's my multiplier?
1/3.
1/3, or you could give me 0.3. That's fine. Where do we start at?
360.
Perfect. Again, 1/3 or 0.33 is going to be fine. I think it's multiple choice. I mean, I know it's multiple choice, but I think it's going to be the fraction. So just be aware of that. How do we tell if it's linear or exponential? How do we tell if it's linear and which one we should use? What's that special number we look at? Where do we find it at? She said 1. Where do we find it at? What's the letter? R. So we're looking for an R that's closest to 1 or -1. All right, so remember in your calculator, if you have your calculator, it's got to be in that stat diagnostic zone. So if we look at this, we put these into stat. So 10, 20, 30, 40, 70, 10, 20, 30, 40, 70. And then you type in your other numbers. This one you might be able to tell as you're putting in your Y's. Can y'all see what's happening in the Y? What's happening in the Y values?
It's going up by 5s.
Not 5, but
Oh,
think about it like money. 62.25, 62.50, 62.75. What's it going up by? 25 every time, right? So if it's adding every time, what are we going to find? Which one adds, linear, exponential? It's going to be linear. Okay, so you can do it without your calculator. Okay, hold on. Did you put in your L1? Make sure you have L1 and L2 up there. You don't? You have L2 and L3? Oh, go back to your stat and edit one more time. Is it up there now? Enter, hit enter. Give me a sec. Sorry guys, just hang on just a second. Somebody just messed with your calculator, that's all. All right. So remember, we got a stat calc and we try linear regression. And what I do is I just make a little note. Linear gave me a perfect 1, so I know it's going to be linear. But just in case, I check my exponential, so stat calc exponential, and I check out my R value there. And it's real close, but which one is the closest? That's what we're looking for. So this one is linear. Okay. If we put our next one in, stat and edit 2, 4, 8, 16, 32, 64. These are crazy numbers. 497, 49.344, 41.98, 30.385, and 15.918. Okay, once you put those in, check both. We're going to stat, calc, linear regression. Let's see what my R is for linear. Negative 0.986. We go back to stat, calc, exponential. And for exponential, my R value was a perfect -1. So which one is this one? This one is going to be exponential because it's perfect. Is everybody good? All right. So that's goal 2. If you want to put a little mark, that's the end of goal 2. Goal 3, sales tax and discounts, what it started off as. Remember, we're using 2 formulas. I'm going to write them down here. Tax is P1 plus R. Discount is the price, and 1 minus R. So tax and discount. You have to know which one to use. So if we look at the first one, it says you buy a new shirt for 18. The shirt is on sale. That means we get money off. So that's going to be a subtract. For 40%, what is the total sales price? So we're going to use P times 1 minus R. P is the price of the shirt. What do we buy the shirt for? What's the price? 18. 1 minus. Remember, we got to change the R to a decimal. So right now it's 40. I move the decimal 2 places back, and I get 0.40. Put that in your calculator. 18. 1 minus 0.4. And I get that the shirt was $10.80. Y'all, that's it. Put it in your calculator. The next one says you buy a pair of pants that cost $58. The sales tax is 6.75. What's the total price? So tax is P1 plus R. Our price of our pants are 58. Your rate, take your decimal and move it back 2 places. Make sure you fill it in. So 0.0675. That's where people tend to make mistakes. Put it in your calculator. 58. 1 plus 0.0675 gives us 61.92. So they will round it for you. Watch that rounding, okay? Any questions on those 2, sales tax and discount? They're fairly easy. And then our last page. Remember your percent of change. Is how far it is from 1 on a number line. So I'm going to start with 24. That's this number right here. How far is 1.25 from 1?
$25.
That's your answer. 0.25 is your percent of change. If they have it as percents, it's going to be 25%. Move that decimal. Okay. Look at this one. Subtract it from 1. 1 minus 0.65. If you get a 65 on your test, how far is that from 100? 1 minus 0.65 is how much? 0.35 or 35%. I don't care which one you give me. It all depends on what your multiple choice answer is. All right, Hunter bought a four-wheeler for $32,000 in 2010. It should say the four-wheeler. It doesn't matter. Will depreciate at a rate of about 13% per year. How much will the four-wheeler be worth in 2020? So remember, this is the same thing as sales tax and discount. We just have a different power. We have a power added to it, okay? So is this one increasing or decreasing? So we're going to subtract. So we're going to take our price, 1 minus our rate, and then how many ever years that we're doing it. All right. So what was the price of the four-wheeler? 32,000. 1 minus, what is our rate as a decimal? Yeah, we take that decimal, move it back 2 places, and we get 0.13. It said he bought it in 2010. It wants to know how much it'll be worth in 2020. So how many years passed? 10. That becomes your power. And literally just put it in your calculator. 32,000, 1 minus 0.13 to the 10. And that four-wheeler is worth 7949.55. Y'all, that's it. Just put it in your calculator. So the only thing between tax and discount and growth and decay is that you actually have a power on this one. Tax and discount, you don't, because you only do it one time. All right. Sadie invested $8,000 in a bank account. Sorry, we're almost done. That earned 3.5% annual interest. If she doesn't withdraw or deposit any money for the next 18 years, how much money will she have in her account? So are we increasing or decreasing? Increasing. So it's P1 plus R to however long you're doing it. What did she put in there? 8,000. 1 plus. Our rate was 3.5. We need to make sure we make it a decimal. So move it back 2 places and fill in what you can. 0.035. And how long are we going to collect in her account? 18 years becomes your power. Put it in your calculator. 8,000. 1 plus 0.035 to the 18. 14859.91. Guys, that's it. I'm going to tell you one more time. Your test looks just like this. So if you're taking notes on this and you get a little bit stuck on your test, you should probably get them out while I'm not looking at you. Everybody got it? Okay. During a certain period of time, a high school population had an annual growth rate of about 4% per year. This year, there are 750 students enrolled. Write the next now rule to describe this situation. So next equals now. What I want to do first, though, is write my, is it growth or decay? So it's a plus like this, okay? What do we start with? One plus, our rate was 4, make it a decimal, so 0.04. And then we don't know how long. We don't know how long, so we're going to put our X. Remember that this number is your multiplier. What is 1 plus 0.04? That is what goes next to your now. Next equals now times 1.04. Where did we start? What's the only other number we've used? 750. That's it. It asks what the size was after 6 years. How do I figure that out? 750. 1 plus 0.04 to the 6, 750, 1.04 to the 6, gives me 948.99. That's it. 2 more just like that one. You're considering buying a car that costs $21,000. It is predicted that the I don't know why the names are changed, will depreciate at a rate of 15% per year. So let's write that. Depreciate means minus. So 1 minus R to the T. What was your initial cost? So we started at 21,000. We did 1 minus, how much is it going to depreciate? Which is to the X. Remember, this number is our multiplier. What is 1 minus 0.15? 0.85. So here's our next now rule. Next equals now. What's our multiplier? 0.85. Where did we start at? Perfect. 21,000. Perfect. Thank you for answering. All right. So this one's a little weird and we got plenty of time. I'm not going to rush it. It wants it to be half its original. So when you see this, half of its original, what was its original? So we're going to divide that by 2 to get half. So 21,000 divided by 2 equals 1050. I'm sorry, 10,500. So what we need to do, follow these steps. Put equation NY equals, and then look at the table. And you're looking for that value, that 10,500. Got some crazy stuff in here. My equation, the one from before, I started with 2100. My multiplier was 0.85 and to the X. So literally put your equation in. And then go to your table. So second graph, and mine may not be where yours is, and that's okay. Mine is at like a negative craziness. Yours should not be there. There we go. So at 0, the start, it was 2100. Keep looking at Y1. When does it get to be at least half? At 4 years, it's at 10,962. Is that halfway yet? No. So when does it finally get there? When does it get there? How long does it take before half is left? Look at it. 3 years had 12,897. I'm looking for 10,5. Where would 10,5 fall? At 4? At 3? Approximately 5 years, right? It would take 5 years before it was in half. If it says more specific, it might say between 4 and 5 because 10,500 falls between 4 and 5. All right. That is it. That is your test review. I'm going to stop sharing, stop recording.